All right, did you come up with a strategy for question number 1, letter D? Because I'll show you how to use the formula, since that was a strategy I picked. I personally think that the formula is a little bit easier to use in problem letter D because most of the information I need for the formula is readily accessible to me with only the information I can access just on the text itself. I don't actually have to do any extra work. Here's why. If I think about this original series, even if I extend it by 5 additional terms, the first term is going to remain unchanged. The first term of the series is still 2. So a sub 1, that substitution, is still going to be 2. If I keep the series going, the multiplier is still going to be 5. It's going to keep multiplying by 5, but the multiplier itself is still 5. So I'm leaving that quantity completely the same. And n, which is the number of terms we're adding up, is something I can easily figure out. There are 1, 2, 3, 4 terms. And if I'm extending it by 5 additional terms, that's 4 plus 5 more terms, that means I'm adding up a total of 9 terms, so I know n is 9. If these formulas that we're using only require a few things to plug in, and I already know what those things are, let's make our life easier. Let's just go ahead and plug them in. So making my substitutions, a sub 1 is going to be 2, parentheses, 1 minus r, which is 5, to the power of n, which is 9, all over 1 minus r again, which is 5. Looks pretty doable to me. That looks quite easy. So let's see if we can do this. 2 times 1 minus, now 5 to the 9th is going to be quite a large number, so a calculator might be helpful here. You have 1, 9, 5, 3, 1, 2, 5, yuck, over 1 minus 5, which is negative 4. So this is where you could do a little bit of cleanup. I personally, I'm going to advocate for just using the calculator at this stage. So we have 2 times parentheses 1 minus 1953125 divided by negative 4. And I end up with, whew, this is a big number, 976,562. Now, if that's the answer you got, and you did it with the formula, that should hopefully reinforce that you were totally instinctively on the right track. If you got that answer another way, it may have been because that you looked at the actual series. And if you wanted to do that, in other words, if you actually extended the series each individual term and then added all of those things up, it does work, and I'll show you quickly why. I'm kind of cheating the process a little bit, and I'm using my graphing calculator to quickly generate all of the numbers from the 0 term to the 9th term. In case you're wondering how I got this, by the way, in my y equals, I just typed the explicit equation, 2/5 times 5 to the power of, now I wanted n, but I had to use x, because that's just the variable my calculator uses, but no big deal. And then in the table, sorry for the glare, but hopefully you can see it, in the table you can tell we have all of those values there. We have 2, 10, 50, 250, 1250, 6, 250, 31250, 156250, and 781250. If I added all of those values, 2 plus 10 plus 50 plus 250, and so on and so on and so on and so on and so on, I would get 976562. Now, the question, of course, is which way is better? Which one is easier? And that's not a question I can personally answer on your behalf. If you have access to a graphing calculator, and if it's not too tedious for you to do stuff like this, then that's a perfectly great strategy that you should totally rely on. The downside is if you don't have a calculator, or if you anticipate being in situations in math analysis where your teachers might say this is a no calculator task, then of course you might not want to be dependent on the tool with no other backup plans. So knowing the formula, or at least being familiar with the formula, might be a wise backup. But some people prefer to just use the formula because they figure it's easy enough for them to plug in the numbers. So you just kind of have to evaluate for yourself and decide which way works best for you. But now that you've seen the formula, which is really part D, then in question letter E, it says extend the original series by 9 additional terms, and then to try to find the sum again. It's also going to ask you in part I, is it still efficient to use basic addition? I'm going to leave that up to you to answer, because I would venture a guess that is to say, if you don't have a graphing calculator, it's probably not very efficient. But if you do have a graphing calculator, it might be. So there's no right answer to this question, question part 1 under letter E. It's really personal to you. In your situation, given where you are sitting right now and the tools you have, is it efficient for you to do it this way? Because if the answer is yes, explain why. Explain what tools you have. And if the answer is no, explain why. Explain what tools you're lacking, or explain what it is about the formula that appeals to you better than using a graphing calculator or basic addition. In any case, between now and the time you start the next video, try question letter E and double down on the method that you chose. If you're using basic addition, do it again. Make sure it still works for this problem. If you're doing the formula now, then do the formula and make sure it works. Just don't forget to check the learning plan, click on the answer key, and check the answer that you get to letter E to ensure that what you're getting is correct. If it is, then I would say the method that you're using is going to work for the entire rest of the page, and you should stick with it. If it's not working and you're getting the wrong answer, try it another way. If even that's not working, then I wouldn't necessarily continue with these videos quite yet. I would stop and either consider a rewatch or consider popping into the office hours the next time they're available and asking a question so that you don't watch the rest of these videos feeling like you're wasting your time on things that don't make any sense. Once you know it makes sense, then proceed to the next video where we're going to do question number 2.